Okay, I think we can start right time and we can get home early. I'm Sivagar. I'm from Google, and this is part of. It's more like some smaller, in-depth things in OSF. You can think about it in that way. So basically, what I'm trying to come up here is like, so we have like Linux boot, we have core boot, all that like high-level stuff, right? And now when the things are a little bit mature, right now I think OSF is a matured state, so we have to dive deep into like different interfaces where we want to be like much more standardized and much more, interoperable with different things. So this is came up with based on that finding, what I worked with on different areas, right? And this time I'm going to talk about mainly the DRAM training data interface. Again, its main thing is, its main call to action basically to work as an industry, come up with a standard so that we can all have the common interface. So if you even think about it more like DRAM as such is a technology, it's like a DDR4, but if you work on different chipsets or different architecture, we have even different types of ways to access the data or get the data, like timing information, training data. So what I am proposing is like we should come up as a common standard so that we can write common interfaces to address general DDR4 or DDR5 things. It's across all the different architectures. So that's where I'm coming from on this one. Okay. And this is the agenda, so let's go through that one. Of course, so we like open source and open standards, and you can see it in all the different endeavors we have with Ron and the team on open, OSF related contributions and all the different things. So we think it's open is like, it actually provides much more robust software, and we had seen in different areas, right? Linux, we know the success, and now the Open BMC. And we are also seeing it in Linux boot, where like multiple vendors come in and provide additional things and make the things much more secure compared to closed architecture where like very few people understand the code. And also like even there is a security problem. You don't have, how to say, expertise in that one, right? Even in our group, we have to go with there is a group for security system. So they understand the things much better than us to look at the different things. So open source and open standard actually provides that thing. So there are some industry level people who actually try to mitigate all these things. So that's why I like open source and open standards, and we are committed to that one. And this is aligned with that area. And also then again, there are industry standards and benefits like we all already using it like PCI, USB. So all these things actually changed our life. And you can imagine like before we used to have PS2 and all the different connectors, MCA. And now we just, in my laptop, I have only USB-C connectors, right? And this all only due to the industry standards we come up with. So there are a lot of standards. And in PC, we have DMTF have a lot of specifications, including Redfish, and ACPI is well established. And even though it's not fully utilized in Linux side, we have some of the thing, but it's one of the powerful architectures on the, right now in the industry. But still, with all this, there are some holes on certain areas, right? We are trying, one of the thing I'm coming up with is the DRAM timing related things, which is not in any of the specifications. Even though JTAG provides the general DDR4 things, but what data is exported is not a standard. Okay, so DIMM training. So it's used to be like I'm writing BIOS from 1995. So it used to be, we had developed BIOS which is like 64 KB or much lesser, and with like 5 files, I clearly remember, and it's all uncompressed. And the memory direction is very simple. You just take the code, write some registers, and you're done. You actually size the memory. There is ED1 thing. But right now, it's totally different because we have high-speed interconnects, whether it's a PCIe, or it's a DIMM. So every line has to be like properly trained between the two ends, right? So there's a very good link which Ron have on the explaining why BIOS is complicated. It's actually, he wrote it for the Linux people, why the core boot is harder. And that's a very good one. You should go through it. So in that one, he mentioned like what is basically training is the process of iteratively putting data on the bus and then make sure that we have the right timing programmed on both sides, right? So that's a basic training. And right now, in most of the thing, it's a reference code actually does that heavy lifting. So in Intel architecture, they have their own hardware-related training generators. I mean, like hardware programming, basically like writing some sequences and read it back and get the rank margining and then make sure that programmed in the right timing signals, right? So, and that involves actually many things. For example, if you take a DIMM module, it has what we call it a SPD, serial presence detect, right? It's a NVRAM, EEPROM, which has the information about the DIMM. And so the DIMM going to say that what is my speed and what are the different things I can support, the timing levels and thing. So based on your chipset, you read the data and then you take the timing values and based on your chipset and additional modules in the channels and you try to program the things. And it's like a very big step, right? And this is the current architecture where memory controller is there and the training code, memory reference code, which actually trains the thing. And then it writes the data into the memory, which is in the form of hub in that UEFI environment, right? And this actual hub is like more, there is no standard basically. Every architecture have their own way of exposing the data, what it is, the trained data, the timing values and all the other thing. And these values are later actually exported to SMBIOS or ACPI to create, for ACPI, that data is used to create the NUMA tables like SRAT, SLIT, and all the other different things. And for SMBIOS, it's mostly for error information and the memory topology and all the other information. Like SPD also has a serial number and all the other things which is exposed. And then there is a higher level software where the BMC and the drivers come in. And so when we have BMC, that's like out of band management, right? So they have to, again, go through all this information, go through read the SPD information and all the things. For BMC, usually it's go through the PECI interface in Intel architecture. And in many cases, they directly read the SPD. And that's not actually a scalable solution because if you enable some closed loop thermal throttling or other methods where the hardware actually accesses the SPD at the same time, then there is a clash because SPD is through I2C bus, SM bus, which actually doesn't support multiple masters, right? So multiple access at the same time. So we need some way to expose the thing. So I was looking at various ways of getting the data. And also this data is very useful. For example, there is a rank margining information. So you can clearly say how much margin you have for a particular training DIMM. And it's very critical when you come up, like in the runtime of the system. So if the margin is getting lower, probably you might want to schedule the system for the DIMM for replacement, right? And you don't want to run the rank margining all the time. You might need to run it on certain times. And only during like certain boots or certain stages. So how these things are handled by the higher level software, not by the host. The host cannot make the decision because somebody in that place, I have to decide like, okay, this is the right time I migrate my VMs and other things so I can now shut down the system and do the maintenance for that particular things. So we want some way to expose the data. And these are the various different interfaces right now available. And like I said, I noticed that there is a BDAT data, which is the BIOS data ACPI table, which is part of ACPI spec, except that actual BDAT content is like proprietary information. So, and it has a lot of valuable information. And also that changes a little bit between different variations, right? But if you think about it, the data it contains, like I mentioned earlier, it's all relative to, I mean, like DDR4 or DDR3, generic information. So that shouldn't actually change between the architecture. So if I look at various chipsets, so I should be able to look at these tables, and then I should be able to get the margining data or anything, irrespective of what platform I'm running, whether it's, I don't care, it's ARM or it's different vendors and different things. So that's where I'm actually calling for, I mean, like come up with a particular specification as a group and then have some common interfaces. So we can clearly say like across the platform, we can get this data constantly, that like for SPD. So we don't need to have the SPD data read during the runtime, right? I can, by the platform like firmware, it doesn't matter, core boot, Linux boot, or whoever, like at the early boot time, we can take the data, store it somewhere in the memory, and either it's exposed to the BMC or the host or the other way mechanisms which can look at the data for access. So you don't need to go to SPD every time. And that's one. And the other thing is, like I mentioned, the RMT data and other timing information. So you clearly know when you boot the system whether your DRAM is running at the right configuration you want. You might be expecting it's running at 2300, I mean, let's say 2666 megahertz, but it might not be, right? Because of some training things or because of some MRC code decided due to some other reason it reduced the frequency. So now you can actually see it from the top level and you can make the decisions. So that's the idea. And again, this whatever I'm saying, like if you want to, what higher level data, I mean, how the training data will be useful in the higher layer, right? So like I said, the RMT data is one of the example. If you know that the margin is little in the particular system, so you can still keep that system running, but don't run something high performance things you want to run on the system, right? So you can do it for batch process where even if it crashes, you can restart the system. Or you can do, I mean, what I mean is before you do the migration and maintenance. So you can keep the systems and have a higher level decisions to be made, right? And again, like you can change the particular DIMM if you want, but when you do want the service. Okay. And again, this, whatever, I mean, things I find during my testing and while developing software on our side of things. Again, and another problem is SMBIOS data structure. So why we access the SPD in the runtime is because when the particular DIMM is disabled, most of the time the BIOS doesn't create the SMBIOS table for that data structure fully. I mean, like it doesn't populate the serial numbers and all the other things. So that actually causes the problem. So we have to, that's why in the runtime, go and check the SPD data and get the data. Okay, so this is SMBIOS structures. And again, I talked about the ACPI tables. What are the different things available in ACPI tables? SLIT, SRAT. Yeah, so the filling the gap is the particular BDAT-based structure. So what I am actually proposing is more like, so BDAT is actually a good table which is already there, and it's designed in a nice way. Basically, it consists of a lot of schemas. So we can add schema which is based on GWIDs. So we can, as a OSF, I mean, we can come up with a standard clearly saying, okay, this GWID contains this type of information, which is standard across architecture. And it can be filled in by various modules. It doesn't matter whether it's from EDK2-based modules or a core boot or anywhere. So we read that data or get it from MRC using FSP and expose it in a standard way for the higher layer. Okay. Yep. And this is just some of the things I learned from the BDAT, which I already let Intel know about it. And we, probably we can start from that point. I mean, take the existing BDAT and come up with our own schemas or take the current schemas and then go from that proposal. And actually, it creates a lot of things. Right now, I'm trying to create some standard drivers so that we can open source the kernel driver. So what it means is like you can get the sysfs-based exposure for in kernel, in Linux kernel, and you can do the same thing for Windows too. And you write once the driver, and you can get all the data exposed. So now the higher level, even user level drivers can look at the data and then make some other decision, whatever they want to make. Okay, that's the call to action. And it's not only like whatever I'm saying, it's basically it's a data structure, right? So it can be exposed to anywhere. Even you can take the data, put it in Redfish, send it to BMC, or anywhere else you can get the data and use it as a thing. So basically, it's a data-driven based approach. Okay. Yep, that's all I have. Yep.
Is there a reason you wouldn't try to push this into the ACPI specification itself?
So the question is, why can't we do it through the ACPI specification? Actually, ACPI has that information on BDAT, but they let the BDAT actual definition to be outside the ACPI specification, right? So that's why I mean, we can. It's not a thing, but at least I want it to be started from as a OSF, and then we can push it to different areas wherever it's supposed to be, right? Is that right, or?
Right. So today, as you mentioned, the BDAT is the raw format of the BDAT is proprietary, right? And when we have different memory technologies that are showing up, DDR4, DDR5, high bandwidth memory, right, NVDIMMs, so on and so forth, the ACPI spec needs to keep up with that, right? That's why it's more free form raw data right now. So, and if you put in the ACPI spec, then every new technology requires a spec change, right? So that's a little bit more of a long pole in the tent, right? So.
But every new format is going to require a Linux driver change.
Right.
So you're just suggesting to keep it separate so that we don't rev the ACPI spec as often as the memory comes up?
I mean, that's one thought, right? But we still have to go and explore if that is feasible or not. If that works, that's probably the best way to go, right?
So actually, there is two parts, right? That's why I said the schema part. So you can, yes, you can put it some in the ACPI, which are the common ones. But there are certain things which will be totally different, right? And which specific to a vendor. Maybe when you want to do it in a Redfish, you want to have certain different information from that one. So you have to create different schema. But like Sarthi said, if you go through the ACPI, it's like a long pole. So we can have the standard one. For DDR4, we need this schema. For DDR5, we need this schema. That we can push it to ACPI. But there are other things, we can still keep it as a OSF or even other forms.
Okay, even OEM specific in their own cloud, for example.
Yeah, if something else specific, yeah. Yeah. Yes. Yeah, okay, ask.
If PD information is, even you don't provide, people can read it. There is a standard way to read it or anything, right?
Yes, which is true.
The memory controller is very proprietary. Even the bus, Intel bus is not 100% compliant with JDAT.
Yep. No, but that's what I'm saying, right? So the question is like the controller, I mean, SPD is common, but not the controller-related data. But even whatever the controller does, you need specific things to understand the controller. But what I am looking for is what timing the controller actually programmed, right? Which is standard, which is JDAC standard, right? So like what value is supposed, TCAS, what is the value? What is the TRS? All the different values. So that I want it to be exposed, which is common, but not the controller level details, which is proprietary, which you need a driver, which you need to understand, which is totally different. Do you understand what I'm saying?
Yeah.
So there are two different things.
Even the thing is, you have to evaluate what is the other value that you can program. Is this standard or it's actually very proprietary? Even like when my experience, when we don't ask Intel, we don't know.
Yeah, that's why I put it in the open. So let them open up the right things. So, and then we can push from there. So.
Unless everything is open, very standard, everybody try to do some security, especially for the digital time.
Yep, I agree. Yep.
So, kind of riffing off the discussion we had earlier today, where do you see all this information like being coalesced and populated? Because obviously, memory init code needs this timing information, and various other parts of the boot phases might use this information in different ways. Would you expect this stuff to all come in very early on, like pre-memory, or would this all be probed again later on and then coalesced into the BDAT structure when ACPI tables are generated?
Yeah. So the question is like where the data will be, and because BDAT is a ACPI table, which is we need it only in the runtime. So, but the data is created at various stages. So where it will be. So my proposal is to, like, for example, it depends on the initial who actually do the memory training, right? So it can be FSP. If it is FSP, it will provide it in a standard way. We clearly say like it can be a hub, because if it is based on, right now it's based on DX, I mean like PEI and other things. So in that case, we define a standard hub. And so the final goal is the BDAT, which is exposed to the other thing. But in each stage, we actually create the standard clearly saying that, okay, if this will be a part of this particular hub, which is a OSF hub. And we define that standard. And it will be part of the PEI. And that will be exposed to the next layer. So it depends on the next layer. Next layer can be a core boot component, or it can be DXE driver component, so which actually builds that BDAT table. But for maybe in core boot, we don't even need a BDAT table, right? You just take the hub and you consume as a Linux driver, and then you do whatever you want to do. So that's the idea. But still, I want it to be defined as part of the OSF with the clear things. Yep.
So other than checking if the DRAM is running at the full speed or not, what are the other example use cases for the OS to know all this DRAM?
So for us, actually, the one I stumbled on mainly is because of the SPD information. Basically, you get the SPD data during the runtime because of the closed loop thermal throttling. And the another one is like we were looking at is the rank margining data. So if you look at the current MRC, you have to set some bias setting to run complete rank margining training and then get the data. And you have to look at the data to find the things, right? But you can enable it in the MRC every time it actually runs it and outputs it. But nobody looked at it, properly. So, but when we try to do like training and try to understand the system, like whether the margining actually the DRAM is like the life is decreasing. Then we notice some of the cases the rank margining data is, it actually gives you a signal. But we didn't look at it. So now that's one of the reasons I want to look at that data as exposed and then look at the data and the things. So two things, basically rank margining and SPD. Yeah.
So based on that comment, there is a penalty, runtime penalty for anything like margining?
You mean that's only, rank margining is only running during boot, right? Yeah. Yes, but if you think about servers, we don't reboot as many time as we usually do, right? It only runs in different things. But that's a different set of problem. Even I want the ability to BMC to tell me to run the rank margining in particular boot, right? I don't want it to run every boot. Maybe I will set it up such a way that I run it every once in a month and then get the data and something like that.
So do you still provide the old data then when you don't run it?
No, we don't provide the data at all, or just keep the same thing, whatever it is. Because we only, externally, we only look at every month and then try to get the data. Yeah. Okay.
You also earlier mentioned there might be some security purposes this can be useful. Can you elaborate a little bit?
Security. Let's see.
Like what kind of security exposures
Actually, that should be general open source related thing, nothing to do with the particular BDAT table. So generally, like why we do open source and things like that, but nothing to do with this part, actually. Yeah. Yep.
So can you talk more about the statistics that you get between the rank margin and the failure that you see?
Actually, it's very early to say. Probably I will, yeah, I'm trying to just get the data right now, and probably some other time later. Right now, it's very few. I mean, the data we have is very little. Yeah.
So, yeah, just a follow-up question. Instead of going from the BIOS to OS, have you considered from BIOS to BMC?
Yes. So that's why I'm
BMC on servers?
BMCL. Sorry.
Sorry, I heard a long time ago that your server doesn't have BMC.
Yeah, but we are moving towards the open BMC and things. So we are getting that side. So that's why I mentioned in the last, like this, it's a basic data structure. Like even it can be from the hub, you can expose it to Redfish or other mechanism or even IPMA to push the open BMC, or you can have other mechanism from the host to expose to the BMC. So I'm still let it open and to come up with other particular way of doing it basically, so that it can be done out of a band.
Based on what you said, for the BDAT, is there any size limitation? Because as I know, for IoT, every time you enable it, it will create a lot of data, up to megabyte.
Yep.
Yeah, so if you put it in BDAT, that would be like, you will make.
Actually, BDAT doesn't have that much information. If you look at it, it's only going to give. So the proposal I want to have is like much simpler one. I know Intel is looking at that one in the next platforms where the data will be much simpler, so that you only know, because we don't care like what are the minor things like where the I fall. I mean, it's bad, right? We only care like, okay, I have only this much margin, or my margin is getting lower, and so that's the data I want to have. I don't want to have.
Analyze the data first, then you start to record what kind of data you want to see.
Yeah, just like get the, from my previous run to this run, how much is like it differed, or like that's what I want to care. So just a simple metric to get it out. I remember the RMT data in BDAT doesn't have that much. It's like simple amount, like how much margin you have on different signals in the right now in the BDAT. Because the one you enable and which shows actually shows the complete eye diagram. So that's too much data. So after that, at the end, it will actually show you like how much margin you have, which is in numbers, clear numbers.
Yeah, for each row, right? For each bank, each bank.
Yep. That's still not much for 96 DIMMs. I calculated I had like 300K, so should be okay.
When you full loaded in
Yep.
X socket, 4 DIMMs.
96, yeah. 300K around. Yep. Anything else? Okay, thank you.